In this video, we're going to see how inverse matrices can be used to encode and decode messages. This involves two things. It involves an encoding matrix and a decoding matrix. The inverse of the encoding matrix is the decoding matrix. Okay, so first of all, we're going to use this this numbering for letters as a guide. So I'm going to use let's see, 0 for blanks, and then of course the letters are going to be numbered 1 through 26. So what we want to do is we want to encode the message math is fun. And this is our encoding matrix. Alright, so how this is done, and let's talk about the kind of the theory behind this. We're going to take our matrix A, and I'm going to multiply it times another matrix B, and that's going to give us a matrix C. So matrix A will be the encoding matrix. The matrix B will include our original message. So we're going to multiply the original message matrix by the encoding matrix, and we're going to multiply on the left. So the encoding matrix will be on the left, our original message will be on the right. C will be the encoded message. So we're going to get a matrix that has the encoded message. So we're asked to encode the message math is fun. Alright, so M is 13, A is 1, T is 20, H is 8. I'm going to put a blank because I want to separate the words. So I'm going to put 0 for blank. And then I is 9, S is 19. I'm going to put another 0 for the blank. And then F is 6, U is 21, and N is 14. So one thing that we want to think about here is the size of our matrix. So the encoding matrix is a 2 by 2. In order to multiply B on the right side, we know that the two middle numbers have to match. So it has to be a 2-row matrix. It has to have 2 rows, and we don't know how many columns. Okay, but we know it has to have 2 rows. So we're going to make the matrix, 2-row matrix, by kind of weaving in and out. So I'm going to start at the 13, and then below that I'm going to put the 1. And then I'm going to go to 20, and then below that I'm going to put the 8. And then I'm going to do 0, and then I'm going to put the 9. So we're kind of going up and down, kind of weaving in and out. So then 19, and then 0, 6, and then 21, and 14. Any empty spaces, we're going to put blanks. I'm going to put a 0 there. So this is our, I'm going to call this B, this is our original message. Alright, and we're going to multiply that on the left by our encoding matrix. So I'm going to multiply that by 1, 1, 2, 3. And this is our matrix A. So this is our encoding matrix. Okay. And we're going to put that into our calculator and multiply A times B. And the result is our encoded message. So when I multiply those two together, we have a 2 by 2 matrix, and I'm multiplying that by a 2 by 6 matrix. So we know that the matrix multiplication is possible and that our result will be a 2 by 6 matrix. So I put that into my calculator, and I get 15 over 16, and then 36 over 44, 18 over 27, 19 over 19, 48 over 69, and then the last entry is 14 over 14. Okay, so this is our encoded message. Alright, now this is what you would send to your friend. So this is the encoded message. So your message would be secure, so you would send that to your friend, and then your friend would need to decode the message. So let's talk about how we're going to decode this message. Okay, if I want to decode the message, we got to go back up to how it was originally coded. So let's go back up a little bit here. So we have A times B equals C. So we have our encoding matrix, original message, and then our encoded matrix C. So this is A, B, and this is C. So we did A times B, which gave us C. Now what we have to do in order to undo what's been done is that I need to multiply both sides by the inverse of the encoding matrix. And I have to multiply both sides of the equation on the left. And that's really important. Now we know that A inverse times A will give us the identity matrix. So it'll be the identity matrix times B. But we know the identity matrix multiply times B will give us right back to B. So we have A inverse times C. So if I want to get back to the original message, and that's the matrix B, if I want to get that all by itself on one side, then I have to take my encoded message here, which I have to take C, and I have to multiply on the left by the inverse of our matrix A. So our inverse matrix has to be multiplied times that encoded message C. Okay, so we can put that into our calculator and figure out what that is. So now what's really nice is that your calculator can find inverses very quickly. There is a button on your calculator that looks like this. It has a little X with a little -1. So all you have to do is actually pull up the name of the matrix in your calculator and touch this button, and it'll put a little -1 right next to the matrix, and that'll actually give you the inverse matrix, and then you can multiply that by the matrix C. Okay. So if you multiply on the left by that inverse matrix, whatever that is, and we don't have to know what that is, your calculator will calculate that for you, multiply it times C, and you should get right back to your matrix B. Okay, so it'll give you right back to this message. And then once you get that matrix B, then your friend could read your message. Okay. Alright, so we have to multiply on the left by A inverse. Okay. So let's look at how we might decode a message that we don't know what it is. Okay. So here we have our message. So our friend has encrypted a message for us, and the message comes back this string of numbers. And we are told that the encoding was done with this matrix A. So we need to think about how this was performed. So what your friend did is he took the matrix A and multiplied this by the original message to get C. So A, once again, is the encoding matrix. B is the original message. Okay. And C will be that encoded message. So we actually need to figure out what C looks like. So we know that we have A as a 2 by 2 matrix. We know that we want to solve for B, which implies, once again, that what we want to do is we want to find out the inverse of matrix A to decode, and we're going to multiply both sides on the left by A inverse. So if we want to figure out this original message, then we need to figure out what C is, and we need to multiply on the left by A inverse. Okay, so let's figure out what C is. So here's our message. We know that B, let's say this, we know that A is a 2 by 2 matrix. So A inverse is also a 2 by 2 matrix. And so we need C, whatever we do with these numbers, we need C to be a 2 by something. Okay, so we're going to form our matrix C. And we're going to do that by forming 2 rows. So we're going to kind of do that zigzag pattern again. I'm going to do 15, and then I'm going to write 16 below it. Then I'm going to go back up and I'm going to write 16, and I'm going to write 74 below it. Then I'm going to write 15, and then I'm going to write 18 below it. So I'm going kind of zigzagging pattern, filling columns rather than rows. So 43, and then below that 62. And then 2, and below that a 3. 28, and then below that a 33. And then 12, and below that an 18. And then 49, and below that 63. Okay, so this is my matrix C. So once again, and you should already have this one in your calculator, once again what we want to do is put matrix A and matrix C in our calculator, so we want to type those into that matrix using that matrix button. Once we have those two in our calculator, then what we can do is we can take A inverse, like we said. So do A and then hit that little button with the little -1 at the top right. And we're going to multiply that by our matrix C. Okay, so we're going to do matrix A inverse on the left. I'll go ahead and kind of write that out for us. So this should be our matrix A inverse. We're going to type that in our calculator, and then we're going to multiply that times matrix C. And when we do that, our calculator gives us our original message. So it gives us this matrix we'll call B. And it looks like this. So we get 13 over 1. And then I get 20 over 18. 9 over 3. I get 5 over 19. 0 over 1. 18 over 5. 0 over 6. And then 21 over 14. So this is the original message that my friend wanted to send to me. So I'm going to decode that. We're going to go back up to how the letters were actually numbered. First of all, let's kind of write out, remember it's zigzag, so as I read it off, I have to go down the columns. So I'm going to read down here, and then down this way, and then down this way. So I'm going to write out my numbers here. 13, and then 1. And then I'm going to go back up to 20. And then 18, and then I'm going to go back up to 9, and then 3, and then I'm going to go up to 5, and then 19. Now the next one is a 0, and remember 0 is a blank. You know that. So I'm going to go ahead and just skip down to the next row to write my next word. So that would be starting off with a 1. Okay. And then 18, and then 5, and then I end up with 0 again, which is another blank, so that's the next word. So I'm going to go down, I'm going to go to 6, and then 21, and then 14. And that's where the message stops. So if I go back up to my my system here for how I numbered the letters. All right, so we're going to use this right here. If I go back up to that and I start to decode, what's the first number we have? We have 13. So 13 represents an M. Okay. So that would be M. 1 is A. 20 is a T. 18, and that list stands for R. 9 is I. 3 is C. 5 is E. And 19 is S. All right. 1 is A. 18 is R. 5 is E. And then we have a blank again, so we have matrices are 6 is an F, 21 represents a U, and 14 represents an N. So we get our encoded message here, we decoded it, and now the original message reads, matrices are fun. Okay, so just kind of an interesting application of these inverse matrices. All right, see if you can use this encoding matrix here to make your own message, and then see if you can give it to a friend and they can decode it.